In recent years, researchers have discovered that bacteria in the gut are necessary for robust responses to chemotherapy and immunotherapy, but their effects on radiation therapy remained unknown. Now, research published in Cancer Cell on July 29 demonstrates that not only are gut bacteria vital to radiation's ability to fight tumors, but fungi, less famous members of the gut microbiome, may act as additional key regulators of the anti-tumor immune response. The paper represents the first demonstration that intestinal fungi may affect anti-cancer radiotherapy, writes Giorgio Trinchieri, a cancer and immunology researcher at the National Cancer Institute who was not involved with the work, in an email to the scientist. I consider this paper an important contribution to the field. Researchers know that gut bacteria and fungi affect immune system function, and recent studies have shown that they also play a role in cancer development. Fecal transplant could boost immunotherapy to treat melanoma. No one had studied the interaction between the microbiome and radiation therapy. So two researchers at Cedars-Sinai Medical Center in Los Angeles joined forces, Stephen Xiao, a radiation oncologist, immunologist, and cancer researcher, and David Underhill, a microbiome and inflammation researcher, to examine it in mice. We saw, interestingly, that the efficacy of radiation was affected by bacteria, like chemotherapy or immunotherapy, said Xiao. The team also saw that when the mice received antibiotics, fungi grew in the bacteria's stead. That was our aha moment, he says, adding that it led to a hypothesis that perhaps an overgrowth of fungus was one of the reasons why, when gut bacteria are eliminated, cancer treatment becomes less effective. They also created fungus-free mice and showed that radiation therapy was much more effective in them than in regular mice. To determine precisely how fungi reduce the effectiveness of radiation therapy, the researchers examined the immune cell composition of tumors from mice that received the different treatments. Compared with mice receiving radiation alone, mice receiving radiation plus antifungal treatment had an increase in cell-killing CD8 plus T cells. In mice receiving antibiotics plus radiation, they saw an increase in tumor-associated macrophages that attack these tumor cell-killing T cells. Killing the bacteria leads to an increase in fungi. When the team removed either these T cells or macrophages from the mice, the antifungal lost its tumor-slowing and life-prolonging effects. In their paper, the researchers write that this likely means that bacteria are important for generating activated T cells after radiation therapy, while fungi promote macrophages that destroy these tumor-killing T cells. If correct, that might suggest that limiting fungi while ensuring a healthy gut bacterial community could boost the immune system's anti-tumor activities. The group is now conducting small trials in early-stage breast cancer patients on the effect of long-term antifungal use on radiation therapy outcomes. Interventions for the microbiome are known and safe, so it could be translated pretty quickly, he adds. Please support my channel to grow by pressing subscribe button and the bell icon. We will notify you technological news. Thank you.